This is question 2 from paper 1 of the 2015 SQA Curriculum for Excellence Higher Maths Exam. We've to find the equation of a tangent to a curve at a particular point. Now, it doesn't matter what the shape of the curve looks like, but let's go through the thinking involved. The tangent is a straight line. And to find the equation of a straight line, we need to know a point on that line, and we need to know the gradient of the line. And if we know these two things, the equation is y minus b equals mx minus a. So that's the formula that we're going to be using. So first of all, a point on the line. We're told that x equals -2, and this is the formula for us to find what the y coordinate is. So it's twice whatever x is cubed, that's -2 cubed, plus 3. Now, -2 cubed, negative times negative times negative, that's going to be a negative answer. 2 cubed is 8. So it's -8 plus 3. And two lots of negative. 8 is -16 plus 3 is -13. So a point on the tangent is -2, -13. So that's that sorted. We have a point on the tangent. There it is. So the second fact we need to know is the gradient. Now, if we have the formula for this curve, y equals, doesn't matter what the formula is, but it involves x, then the gradient is given by dy by dx, or f dashed of x. We differentiate to find the gradient. So y equals 2x cubed plus 3. Let's differentiate to find the gradient. Now, the rule we're using is that if y equals ax to some power, the gradient, you take the power, the index, and multiply. This, any number in front just stays there, and you take 1 from the power. So there's the power, the index, goes down the front 3 times, the 2 just sits there, x to the power, we take 1 away from the power. And in the second part of this is a constant 3. Let's think of a graph y equals 3. That's parallel to the x-axis. There it is, y equals 3. What's the gradient of that? It's 0. If you differentiate to find the gradient of y equals 3, you just get 0. So this doesn't contribute anything to it. So we now have the fact that the gradient anywhere on this curve will be 6x squared. We know we're interested in the point where x equals -2. So when x equals -2, the gradient is equal to 6 times -2 squared. Well, that's 6 times -2 times -2 is 4. 4 6s are 24. So the gradient of the tangent is 24. So that's the second thing we needed, the tangent. So finally, we're in a position where we can use this formula to say the equation of the tangent is y minus the y coordinate of the point on the tangent, -13, y minus b equals m gradient 24 times x minus the x coordinate a of the point on the tangent, that's -2. Well, a bit of tidying up here is required. Y plus 13, take away -13, equals 24 times x plus 2. We'll get rid of the brackets. That's 24x plus 48. And then let's take 13 away from both sides of the equation. So y equals 24x plus 35. And that is the equation of the tangent to this curve at the point where x equals -2.